All right, welcome, good morning, everybody. We hope you had enjoyed KubeCon so far. Today we're going to talk about a very unusual case for using Kubernetes, and that is hosting a CTF competition. So before we start, let's introduce ourselves. So I'm Ariel Zelivansky. I work for Twistlock as a security researcher. I lead the security research team. What we do is basically try to find vulnerabilities in many CNCF and open source projects that we and our customers use. We allocate CVEs and write articles about what we find, but the main thing is we always follow responsible disclosure when we release our findings. So we basically try to contribute as much as we can to open source and cloud native security.
So hi, I'm Liron. I am the chief software architect at Twistlock, and I lead the platform and infrastructure team. That's good.
Okay, so what are we going to do today? So first of all, we're going to talk about what a CTF is. How many of you have tried to solve CTFs in the past? Okay, that's pretty good. It's mainly for security researchers, but everybody can do a CTF, so once you get over to this room, you can try to look up for CTFs and try to solve any CTF you find. It's really good for you to try. So we'll explain why we chose to host our CTF on Kubernetes. Liron will explain a little bit about the engineering of the infrastructure and how it was all done in the background. And then a little bit about the security and how do you even secure a Kubernetes cluster when you give outsiders shell access to your pods by design. And then we'll just briefly show the results of the CTFs and what we took from hosting it. Okay, so CTF goes for capture the flag. Maybe some of you know it from like a capture the flag physical game. The flags are usually like virtual flags, some base 64, some hash that only the guy that solved the challenge can find. Jeopardy style is the most common CTF style, where you have just many different challenges, and you get points for every challenge that you solve, and you try to get as many points as you can to win the challenge. Attack defense is my favorite CTF type. It's where you have two teams or more that try to compete against each other and use exploits or security measures for like either attacking the other team or protecting their own team. And war games is where you have just like one challenge with multiple phases, and you just try to get the final stage and win. CTFs are really good for education purposes. So when some guys come up to me and say like, how do I start getting good at security? Like, how do I learn exploitation? I always say try to solve CTFs. There are CTFs in many different levels. Like there's some for beginners, some for really advanced exploitations, and it's a good way to study security. And many times you see security researchers create CTFs where you have to use the most recent techniques to solve the challenges. So it's really a good way to learn sometimes if you can't find real instances to try to do things. And security conventions usually host CTF, so if you hit up one of the security conventions, just go to the CTF and try. Yeah. So why did we decide to host the CTF at Twistlock? It's a really good way to find security researchers. Security researchers, including myself, really love solving CTFs. We thought we could make an interesting and difficult challenge, and it was a lot of fun for us and our participants to solve this challenge. So as we said, we wanted to find good security researchers. We're based in Israel. So we advertised on Israeli newspapers, newspaper sites. This is one of the most popular Israeli news website. So we put up this ad. And as you can see, like this ad was, it was not clickable. Like you couldn't click on it and get to the website. So can you guys tell what this is? Yeah, that's base 64. It gets you through to the website as soon as you decode this base 64. And it was just some simple way to filter out most of the people that saw the ad. We wanted our CTF to be interesting. We didn't want it to be just another CTF. So what we had in mind was creating a single machine that had all the steps of the challenge. Instead of having, like in normal CTFs, you usually solve a challenge, you get a flag, you input it into the website of the CTF, and then you get the next challenge. We didn't want to do that. We wanted to have a single machine with all the challenges in it. And the way we did it is by having different Linux users on the same machine, and the user would have to get access to these users by escalating his privileges to get the actual next, second, and third binaries. And the flags were just files. And solving the challenge required different sets of skills. The first challenge was like web exploitation. The second one required reverse engineering of some binaries. And then to solve the next challenges, you would need to get like real deep into the Linux internals and know modern exploitation techniques. And like to get the final flag, you would have to write a real exploit that really imitates like a real scenario when you exploit a binary. So this is how the challenge looked like as soon as you got into our domain. There's a little background story about this CTF. Like there's some company you have to hack. It's not a real company, it's our company, so it's okay. And this company is like a virus database company, and they put the hash of like the good company, the T19 company, that we want to get off their website. Okay, so as you can see, this is the binary you download. It's called cat, and it's not a normal cat. It's just like a virtual cat, but it has no flaws in it. Actually, like you just need to upload it and get the MD5 of it and get it off the database. So it's something you wouldn't really use. This is what the challenge looks like from the first entrance point. You have some Ruby server that we wrote, and like the user gets an API for uploading the file, and if he uploads the cat, he gets like, this is the virus danger, and you would want to get rid of that screen and have it pass. Right, so before we even knew like we're going to host this on Kubernetes, this was the design for the challenge. It would be a Linux machine, there would be a Ruby server, and there would be a client binary that would use IPC to get to the database server, which would hold all the hashes. And each of these binaries would be accessible only by the right user. So if the Ruby server is just like a simple Ruby user, then the client would be some other user that you have to access as soon as you get like shell access from this user, and the DB server runs as root. So the way you escalate from having, like the Ruby server has some flow in it that we put in, so you can do a reverse shell and get access to the machine. This is like the first entry point. And so like you go from this screen to like an actual shell. And this client binary is setUID. Do you guys know what setUID is? Okay, so setUID is some Linux file permission that makes the binary, like the client binary, run as the setUID, like the owner of the file, like the user that owns the file. So if this user owns the client file, when this user runs this binary, the effective UID of the process would be that of this user. So if there is some flow in the client code that allows code execution, this user could escalate its privileges and run as this user and get shell for this user. So this is like the second step of the challenge. You escalate privileges to this user. And finally, there would be some flaws in the DB servers and that you could exploit to remove hashes from the database. And we had some watchdog binary that just made sure that everything keeps running, because we're letting users do whatever they want on the machine, and they might like kill the server by accident or by like deliberately, and this watchdog would be something they can't touch that always makes sure this server is running. And each of these users has some flag that they could input to our CTF platform, and they would get points for each flag. but they don't have to. Like, they can actually just go through all the steps and get the DB server like without inputting any flags. And there would be some hidden flag that we put to anybody who managed to get root access in the machine. All right, so yeah, why did we decide to do it on cloud? So it was pretty apparent to us that we can't give the user some VM binary and tell them, okay, run it on your machine. Because if we give them the whole machine, like as a virtual machine image, they could just read out the memory and extract all the flags, and they wouldn't have to solve the challenge. And they could just cheat very easily, and we didn't want people to do that. And security researchers would try to do everything they can, cheating or not, to win the challenge. And yeah, so it would also be very easy for us to manage all the instances of the challenge and control them and make changes to them. And finally, it was interesting for us to see what security researchers would try to do when they get root shell on our pods, like deliberately. There were some similar experiences in the past, like Lambda shell, and it was interesting for us to see what people would do. And why specifically Kubernetes? It's very easy to scale up or down, like adding more instances. We didn't know how many participants are going to start solving it, and Kubernetes makes it very easy to scale up. It's easy to update if we want to make changes to all the instances. It can be really easy with Kubernetes, and the configuration was like perfect for us. You have many YAML files that define the cluster of the CTF, and if we want to first try and host it locally with Twistlock employees, we did that, and then we took like the whole configuration file and we put it on GKE, and it just like we didn't have to change anything. It just ran the same way.
Good. So let's talk about engineering. Yeah, I'm doing this. I did this. Thank you. Okay, so engineering. We at Twistlock believe that before talking about... You can hear me? Can you hear me? Yes, it's good. Okay, so at Twistlock we believe that before rushing to implementation, you need to think about the engineering aspect and the requirements. And they will assist you later when you build the solution. So what are the requirements of building a CTF challenge over Kubernetes? So first, you want a solution that is simple. Simple, but not simplistic. Simple means that it's easy to understand it, easy to work with it, and you don't need to waste a lot of resources and engineering time to build it. Second, we want a solution that is cheap, okay? So remember, we're going to give each participant a pod. Pod costs you memory, costs you CPUs. You want to limit the amount of resources that you technically use. Third, we want a solution that is reproducible. Now, everybody knows Kubernetes. Everything is reproducible because everything is a YAML. But you want something that will be easy for you if you want to redeploy the entire solution or to scale it up, to do it in a very simple manner. And it can be partially automated. You don't have to be fully automated. You're just going to build like a CTF challenge. You don't need to go wild and build like a very complex pipeline and infrastructure, which is what we did. And finally, you want a solution that is secure as much as possible by default. Now, I put a big asterisk next to secure because technically, nothing is really secure, okay? So everything is hackable with enough resources, but you need to think about how to use your cloud-native artifacts and solution to build something that is secure as much as possible. So I will show you all of this. So how does the solution look like? So we have the participant, okay, up here, okay, and he registers to a portal, the T19 challenge. He goes to the portal. Then here we have a registration service. So in the registration service talks with a database. And in the database, we map each new user to a regular HTTP cookie, okay? The cookie returns to the user. Then the user needs to go to another portal, which Ariel showed you, the Virus Express, where he manually enters the cookie, okay? This goes to an Nginx instance, which is a simple Nginx installed on our Kubernetes cluster, and we have the following configuration that maps each cookie the user receives to a local cluster IP of a service, a regular Kubernetes service. We have 3 services here. Each of those has a specific IP, okay? And then the user just gets redirected to one of the instances. And we're done, right? Good. So let's talk about how to materialize this idea. I just talked about the overview. How do you materialize this? So we sat and discussed the solution, and we found 3. I assume there are more. So let's see. first, there is the solution where you statically allocate everything. You statically allocate the pods, you statically allocate the services, the configuration in database, Nginx, everything. Now, this is a very good solution if you know exactly how much participant you're going to get, but you can never know that. And also, what happened in our challenge, where we first deployed only for the local Twistlock employees, then in Israel, then in the entire world using Hacker News and Reddit. So you're going to scale, you're going to have idle instances, so a static solution, probably not the best. Second possible solution is to make it completely automated, okay? So we had the registration service. Every time a participant registers to the challenge, we create a new service, we create a new pod, okay? So everything is completely automatic. Sounds good, right? So it is good if you're going to build like your production solution, but for CTF, we think it's a little bit too much. First, it's a little bit complex. And second, there is the security issue where now the registration service needs to talk with the API server, so you need a token. So we kind of dropped that. And finally, we reached the hybrid solution, which is what we showed, what we used, and it's really cool. I want to show you that. So how does it work? Okay, so it's based on a very interesting idea. Okay, so the idea is that in Kubernetes, you can tell Kubernetes the subnet to use when creating services, okay? There is a parameter called service CIDR, which tells Kubernetes which subnet to allocate to all new services. Then when you create a service, you can predefine the IP the service is going to use. Why it is so good? Because services in Kubernetes doesn't technically cost you anything. Those are just like routes in IP table that tells like the system how to redirect a packet. So here we had the service. We also have a selector of an app, and the app is just like a pod or application controller, but it was not deployed. We just deployed the services. The load balancer and the storage were statically configured, like we created 10,000 cookies and made them to 10,000 services. Everything was statically allocated. As you can see here, we have the cookie of the user, the cluster IP, same in Nginx, everything is the same. And the final piece is the on-demand pod allocation. So the instances the user was going to use was not created in advance. We started with a relatively small number, okay? And then every time we saw, we reached out of allocation, we just allocate more instances. So we started with 10, then 100, 200, and 1,000. Okay, so you can see each deployment has a selector which matched the selector that was on the load balancer, on the Nginx instance. So this was the solution that we chose. Now let's talk about security challenges when building such a solution. So remember, we're going to give arbitrary user from the internet root access to our clusters inside a container. So what do you need to think about when you're going to implement such a solution? Now, there are a lot of security risks when you do stuff like that, and I don't recommend anybody to do that. But if you have to do that, those are the things we think you need to think about. So the first issue you're going to get is, it's called local resource exhaustion, and it's when somebody just exploit your pod to do something malicious. Now, it can be something stupid, like just kill the pod, okay, or waste a lot of memory or CPU. Or it could be something even more malicious, like installing crypto miners, which is a very common thing. Like if somebody will hear that Twistlock gives you free compute resource, I'm sure that somebody will install a crypto miner in this instance. The second security risk is what happens when an attacker breaks out of the container. This can actually happen. And it can happen because you either misconfigured your pods or your YAMLs, or you have somewhere vulnerability in your infrastructure. Both of those instances really happen. And the third security challenge, which also happens in real life, is when somebody uses some network attack, okay, to do a cluster compromise. Somehow we manage to access your Kubernetes API server or the cloud provider API metadata server, and there's a lot of talks about this subject, and he managed to completely take over your cluster, steal all the images, and it's game over for you because the CTF is over. And these things happened. I have two examples here. So let's talk about mitigations. So there are two simple mitigations you can apply if you want to avoid the first security risk. Technically, when you if you give users a shell inside a container, what you want to do to avoid a crypto miner is just to block all outgoing traffic. Then they can't get out. they can't publish anything, and like it mitigates most of the issues. However, you can do that because in CTF challenges, usually what the attacker does after he perform the first exploit, he will get a reverse shell because it's more comfortable for him. So you can't block outgoing ports because it needs an outgoing port. But you can block most of the common outgoing ports for crypto miners. And then like if you get a remote shell, he will try to manually install a crypto miner. It will not work and he will just give up, hopefully. Again, not a bulletproof solution, but it's quite good and it works. The second thing you want to do is to apply a pod security policy. This is by default not configured. So technically, if somebody inside your pod, it can consume all the memory on the machine and it's game over for this node. So a pod security policy defines like constraints on the pod you can apply. Two relevant constraints for our instance are CPU and memory. It uses C groups. Memory constraint means that like the amount of memory the container is going to use is capped. If the container overflows this amount, it will get killed. And CPU constraint means that like the amount of CPU the container is going to get is limited. And it will just can't consume more resources than that on that machine. And since our challenge was not CPU or memory constraint, it's not a real problem. Okay. So let's talk about the second challenge. Okay, container breakout. So somebody somehow managed to get out from your container to the host. Why this can happen? How can we prevent that? So first, my recommendation. Create a classic container. You look at a lot of production deployment and you see lots of configuration, secrets, mounts, stuff. If you do something like that, keep it simple, only the app, minimal stuff, only things that you really understand. The second thing, you also don't want to touch all the security configuration. By default, the containers in Docker and Containerd come with a relatively good security profile, which limits some of the capabilities the root user can do inside the container, and it also limits the system calls the root can do using seccomp and standard Linux capabilities. Finally, you want to also think about which image you use to deploy your nodes, okay, the host image. It's also important. We use GKE, Google Kubernetes Engine, which by default comes with a container optimized OS, which is a very good and hardened operating system. And one very, very good thing about it, it comes with read-only root partition, meaning the binaries on the node, on the host, can't be overwritten. They are read-only. And this is very, very cool because it automatically mitigates some of the vulnerabilities that exist but were patched in containers. Finally, something that we didn't do, but you will probably want to do if you give user root access, is to use user namespace. It's a little tricky to configure, but what it technically means is that users inside your container that are root are mapped to a regular user on the host, so they are weakened and your container is hardened. Ariel.
Okay, so how do you mitigate a cluster takeover? Well, you can do many things, but the most basic things you want to remember is use an isolated environment. We hosted this CTF. It's not something we normally do at Twistlock, so we've created a new, different project for it, and we didn't just host it on a test environment. And we had a different GKE project for it. And whenever you have some dedicated app that you send to production, you should have an isolated environment. And that is important because if somebody somehow manages to break out of a pod and get access to the cluster or the node, you could only see things that are related to the CTF and not Twistlock images. And it was very important to us to have this different isolated environment in case something does happen and somebody managed to exploit a CV or something and get out. At the time we were doing this CTF, there was also the run CCVE, and we were really concerned somebody will use something similar to break out of a container. One more thing you want to remember is sometimes in cases like the CTF, you don't want users from inside a pod or container to access the Kubernetes API. One way to do that is by disabling the service account token mounting, which would disallow users from inside a container to access the Kubernetes API. And one more important thing is preventing access to the metadata API. Now, the metadata API is something you have in all the cloud providers. AWS has it, GKE has it. it is some IP that when you access it, you can usually using anonymous user, meaning no user login, you can get access about your cluster. So you could see all the images, you could see what is running, you could download the images. That is something we don't want users to be able to do from inside a container that we deliberately give them shell to, because otherwise it would be able to download the images that they're running on and get out all the flags. So we had to block access to the metadata API. And the way we did it was actually using a network policy. So normally, Amazon and Google also have documentation on how you can disable access to the metadata. But you can also just block access to the IP of the metadata API. And that way, the user just couldn't access it. OK, so we had 8 participants solve the challenge. 6 of them actually managed to exploit the final binary and get root access on the machine, which was pretty impressive because we thought most participants would just get access to the third flag. There were some really interesting write-ups about solving this CTF and all the exploitation method that they used. I really recommend reading this after you try to solve the challenge yourself. The prize we gave to the participants was a challenge coin that we molded with Twistlock logo and the T19 banner. T19 actually stands for Twistlock 19, so that means we're gonna have a T20 challenge as well. So you might want to check that next January in 2020. Okay, so what are the key takeouts from having hosted all this CTF? If we plan the engineering right to begin with, we can save a lot of money. Now, money is also resources, like actual running pods that we didn't statically allocate beforehand. But it's also saving time. We didn't create a really complex solution. CTFs are not what we normally do at Twistlock, so we could cut edges and sometimes make some simple solution that is not the best, but it would save us a lot of time in the long run. It was really important to have good security, and Kubernetes is a really good platform to host a CTF on, especially if you want it to go live and you don't trust the user that they won't cheat. You really can control what is happening inside your pods, and you can really easily monitor what is going on. So Kubernetes is a great platform to host a CTF on. You can go to this URL and try to solve the challenge yourself. So since the challenge is already concluded, you do get an image you can play with. We don't host the cluster anymore, so you get an image. So please don't cheat and try to solve it the right way. There are instructions. And yeah, see you in the next challenge. Thank you. So, any questions?
No. It's
No.
It's like root and host. It's like root and host. If you privilege your root and host, even if you're in container, you can think about it's root on the host. Again, if you have a real company that does this infrastructure, I would recommend using another sandbox like gvisor. If you know gvisor? Yeah. If you know gvisor, so gvisor is like a good another sandboxing or kata container or something like that. But if you're going to give random users from the internet access to containers, I don't think it's recommended. You can't trust them. For CTF, it's okay. If the isolated environment is okay, but if this is your production environment, you need another mechanism of security like Google does. And this is also our recommendation. Yes?
Were you able to recruit any of the engineers and solve it?
Ariel? I will repeat the question. Were we able to recruit any of the engineers who solved this challenge?
Okay, so unfortunately, we didn't recruit any of the 8 engineers that solved it.
But you had a good reason. They're not from Israel.
Yeah. Well, they were not from Israel. Eventually, the guys that solved it were from all over the world, basically. So we were only recruiting in Israel. Yeah. Yeah. Anyone else? All right. Thank you so much.